We want to replace these 3 points with a centre of mass. We know that it must have the same combined mass as our 3 objects, so we simply add their masses and get 16 kilograms. Somewhere here we're going to have our particle of mass 16 kilograms, and we'll call its coordinates x bar and y bar. In order to find x bar and y bar, let's collect the information in a table. We take the mass and position for each particle involved. First, let's look at the original particles. We have a 5 kilogram mass at the point -3, 2. We have an 8 kilogram mass at the point 5, 3, and a 3 kilogram mass at the point 2, -3. We want to replace these with our 16 kilogram mass at x bar and y bar. To find x bar, we're going to take moments using the y-axis as the axis for rotation. The distance of each point from the y-axis is simply its x-coordinate, with the sign telling us in which direction the moment will be, whether it will be clockwise or anti-clockwise. So for the 5 kilogram mass, we do 5 times -3. Remember, strictly speaking, we should use weight, but the g will just cancel throughout, so we can use mass times position. For the 8 kilogram mass then, we're going to have 8 times 5. For the 3 kilogram mass, it will be 3 times 2. And this must be equal to the moment produced by the centre of mass, which is 16 times x bar. This gives us -15 plus 40 plus 6 is equal to 16x bar. This gives us 31 is equal to 16x bar, and therefore x bar is equal to 31 divided by 16. To find y bar, we take moments using the x-axis as our axis of rotation. So for the 5 kilogram mass, we do 5 times 2. Remember, the y-coordinate gives the distance from the x-axis. Then we have 8 times 3, and 3 times -3 is equal to 16 y bar. This is 10 plus 24, take away 9, which is 25. So 25 is equal to 16 y bar, and y bar is therefore 25 divided by 16. So our centre of mass is going to have coordinates 31 over 16 and 25 over 16.